Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So today I have came up with an amazing assignment crew problem. So let us quickly move on to the problem and see what the problem is. So the problem says that a trip from Chandigarh to Delhi takes 6 hours. A typical table of the bus service in both directions is given below. So these are the two tables given, and this is departure from Chandigarh, arrival at Delhi, and this is the route. Similarly here, arrival at Chandigarh, departure from Delhi, and these are the routes. The cost of providing this service by a transport company depends upon the time spent by the bus crew, that is driver and conductor, away from their places. In addition to service times, there are 5 crews. There is a constraint that every crew should be provided more than 4 hours of rest before the return trip, and again should not wait more than 24 hours for the return trip. The company has residential facilities for the crew at Chandigarh as well as at Delhi. Suggest an optimal assignment of the crew. So in this problem, it says that the company has residential facilities at both Chandigarh as well as Delhi, and we need to assign the optimal assignment for the crew. So let us first need to find out the time the crew takes, or the time the crew uses for the residential facility of the company. Okay, so I am just erasing the 2 or 3 lines so that it will be easy to solve here. Okay, so now first of all, we know that the crew can reside either in Chandigarh or in Delhi. So if a crew resides in Chandigarh, that means it uses the company facility at Delhi, and if a crew resides in Delhi, it uses the company's facility in Chandigarh. So let us see if crew resides in Chandigarh. So if a crew resides in Chandigarh, we need to see the waiting time there. So the first table has A, B, C, D, E routes, and the second table has routes 1, 2, 3, 4, 5. So when I say if a crew resides in Chandigarh, that means crew has his residence at Chandigarh, that means it will avail the company facilities at Delhi. So we need to see how much amount of time the crew spends in Delhi in company's residency. For that we need to see the arrival time in Delhi and the departure time in Delhi. So the crew arrive in Delhi, and till the crew depart from Delhi, this is the time we need to calculate. So let us calculate first. So as we can see here, this is the arrival at Delhi and this is departure from Delhi. So we need to see that if a crew arrives from route A, okay, and depart from various routes, so how much time they stay at the company's facility in Delhi. So let us see, if a crew came from route A, it came at 12 o'clock, and if it returns from route B, then it depart at 5:30. So the difference of 12 o'clock and 5:30 is 12 plus 12, 24, because this has been given in 24 hours format. 24 plus 5:30, that is 17 hours 30 minutes, or I can write it 17.5. So if a crew arrives from route A and departs from route 1, so the time it spent is 17.5. Similarly, if a crew arrives with A and departs with route 2, so 12 and 9, so 12 up to 12 is 24 hours minus 3 hours, that is 21 hours. So this will be 21. And if a crew arrives with route A and depart from route 3, so the time difference is 12 hours, 13, 14, 15, so 3 hours of rest. This is 3. If a crew arrives from route A and depart from route 4, so this is 18:30. The difference between 12 hours and 18:30 is 6.5. So this is 6.5 hours. If a crew arrives with route A and depart from route 5, so as we can see, the difference is 12 hours here. So this is 12. Now similarly, we will see that if a crew arrives with route B, that is the arrival time is 13:30, and if it departs from route 1, that is at 5:30 am. So let us see the difference between these. So this will be 13:30. This is let us this 14 plus 10 plus 6, 16. So the difference here is 16 hours. Similarly, if a crew arrives from route B and depart from route 2, 13:30, and this is 9. So 6 plus 3, 9. So this will be 19.5. Okay, this will let us be 14 plus 10 plus 9. So this will be 19.5 hours. Similarly, if crew arrives from route B and depart from route 3, the difference here is 1.5 hours. Okay, so this will be 1.5. Then the crew arrives from B and depart from 4, 13, 14, 15, 16, 17, 18. So this has a time of 5 hours. If a crew arrives with route B and depart from this for 10.5, this is 10.5 hours. So this is 10.5. Now if a crew arrives with route C and depart from route A, this is 17:30, this is 5:30. So it is 12 hours. Similarly, if crew arrives from route C and depart from route 2, then this is 12 plus 3, 15.5. So this is 15.5 hours. If a crew arrives from route C and depart from route 3, so we'll see the difference between these two. So 17.5 is 17:30 to 17:30 will be 24 hours, and 24, 22, this will be 21.5 hour. Similarly, if it arrives from route C and depart from route 4, it will have 1 hour. If it arrives from route C and depart from route 5, it will have 6.5 hours, 18:24. Okay, 6.5 hours. Now if it arrives from route D and depart from 1, it will have 1 and 5:30, that means 4.5 hours. This is 4.5. Similarly, if it arrives by route D and depart from route 2, so it will have 8 hours. If it arrives from route D and depart from route 3, so it will have 14 hours. If it arrives from route D and departs from route 4, then it has 17.5 hours. 17.5 hours. Again, it will, if it arrives from route D and departs from route 5, so it will have 1 to 1 will be 24 hours minus 1, 23 hours. So now if it arrives from route E and departs from route 1, so this will be 6:30 to 6:30 will be 24 minus 1, 20, this will be 23 hours. And if it arrives by route E and departs by route 2, this will be 2.5 hours. 2.5 hours. If it arrives from route E and departs from route 3, it will have 7 plus 8. This is 8.5 hours. This is 8.5 hours. And if it arrives from route E and departs from route 4, it has, this is morning 6:30, this is evening 6:30, so this will be 12 hours. If it arrives from route E and departs from route 5, it will have 17.5 hours or 17, okay, 17.5 hours, correct. So we have prepared this matrix where we see that if a crew resides in Chandigarh, then these are the times it will take in the company facility at Delhi. Now we will make a similar matrix if crew resides in Delhi. So let us see, if the crew resides in Delhi, then what amount of time it takes at the company's facility at Chandigarh. So for this, we need to calculate the arrival time of Chandigarh to the departure time of Chandigarh. So we need the difference of arrival at Chandigarh and departure from Chandigarh. So let us again create a new matrix. These are route A, B, C, D and E. These are 1, 2, 3, 4 and 5. So let us see, if the crew arrives at Chandigarh from route A, okay, if a crew arrives at Chandigarh from route A, it is arriving at 11:30, and if it departs from route if it arrives from route 1, it arrives at 11:30, and if it departs from route A, it is departing at 6. So the difference between these two times we need to calculate. So here we can see that the difference here will be 11:30 is 12 plus 18, so this will be 18.5. Now if it arrives from route 1 and departs from route B, it will have the time this, so the difference is this is 12, this is 8, 12 to 12, okay, plus 8, 12 plus 8 is 20, so this will be 20 hours from route 1 to B, from route 1 to B, so this will be 20. Previously we have calculated row wise, now we are calculating column wise, please understand, okay. So if it arrives from route 1 and departs from route C, 11:30, so for this arrival time and departure time is same, so either we can take the value 0 or we can take the maximum value of 24 hours. So I am taking here 24 hours. Okay, so if it arrives from route 1 and departs from route D, so the time here will be 12 plus 7 is 9, 7.5. so this is 7.5 hours. And if it arrives from 1 and departs from E, the time here is 11:30 to 11:30, 12 plus 13, this will be 13 hours. 13 hours. Similarly, if a crew arrives from route 2 and depart from route 1, so this is 15 and this is 6. The difference here is 15 plus 9, 9 plus 6, 15. So this will be 15 hours. If a crew arrives from route 2 and departs from route B, the difference between these two is 1500, 15 plus 9, 24, 9 plus 7, 16. So this will be 16.5. 16.5. Similarly, if the crew arrives from route 2 and departs from route 3, this will be 15 to 15 will be 24. 24 minus 3, 21. This will be 20.5. 20.5. And if it arrives from route 2 and departs from route route D, so this will be 4 hours. If it arrives from route 2 and departs from route E, it will be plus 9, 9.5 hours. Similarly, if the crew arrives from route 3 and departs from A, the time here will be 3 plus 6, 9. This will be 9 hours. And if it arrives from route 3 and departs from B, the time here will be 10.5 hours. 10.5. Okay. If the crew arrives with route 3 and departs from route C, the time here will be 9 plus 3, 24. 14.5. This time is 14.5. If the crew arrives from route 3 and departs from route D, so the difference here is 21 to 21 will be 24 hours. 24 minus 2 is 22 hours. So this is 22 hours. So if a crew arrives from route 3 and departs from route E, so this will be 3.5 hours. This will be 3.5 hours. Now if the crew arrives from route A at this time and departs from crew arrives from route 4 at this time and departs from route A at this time, so the time difference here is 5.5. Now if a crew arrives from route 4 and departs from B, the time here will be 7 hours. If a crew arrives at 4 and departs from C, the time here will be, this is 12:30 minus and 11 hours. This will be 11 hours. If the crew arrives by route 4 and departs from route D, the time here will be 18.5. This is 18.5 hours. And if a crew arrives from route 4 and depart from route E, so we are having the same time, so we can either take the value 0 or 24 hours. So I am taking again 24 hours. And now if the crew arrives from route 5 and departs from route A, so the time here is same, so again I am taking 24 hours. And if the crew arrives from route 5 and departs from B, the time here is 1.5 hours. If the crew arrives from route 5 and departs from route C, the time here will be 6 plus 5.5. So the time here is 5.5 hours. If the crew arrives from route 5 and departs from route D, the time here will be 13 hours. The time difference will be 13 hours. Okay, 6 plus 13 is 19. So this will be 13 hours. If the crew arrives by route 5 and departs from route E, the time here will be, this is 18 plus 5, 18.5 hours. 18.5 hours. So these are the times that the crew spent at the company's residence at Chandigarh, because the original residence of crew is in Delhi. So we have calculated these two values, and now we need to understand that our objective is that the crew spends minimum time at the company's facility. So what we will do is, we will again make a matrix which is a minimization matrix. Okay, which will again makes a matrix will be minimization matrix, and this matrix will show the minimum time that a crew spends at the company's facility. So these are the routes A, B, C, D and E. 1, 2, 3, 4 and 5. Now what we are going to see is, we are going to compare both these two matrices and each cell of these matrix, and whatever will be the minimum value, we are going to select that minimum value in this new particular matrix. But we need to understand that the company has some constraints, that a crew must wait at least for 4 hours before making a return trip. So we need to keep in mind that particular thing. So let us start here. As we can see, cell A1 here 17.5, here it is 18.5. So the minimum value is 17.5. So I have written 17.5. Now cell A2 21 and 15. So minimum is 15. So I have written 15. Here 3 and 9. So as we can see, 3 is minimum, but we need to understand that the company has constrained that a crew has to wait at least 4 hours. So it is less than 4 hours. So we will ignore this particular value and we will select the value 9 and write in our matrix. Okay. Now this is 6.5, this is 5.5. So 5.5 is minimum. 5.5. Here it is 12 and 24. So 12 is minimum. Similarly here 16 and 20. 16 is minimum. 16. Then 19.5, 16.5. So 16.5 is minimum. Here 1.5 and 10.5. So as we have discussed, the crew has to wait at least 4 hours before the return trip. So we could not select this value. So we are going to select the value 10.5. This will be 10.5. And this is 5 and 7. So 5 is selected. 10.5, 1.5. So again this 1.5 will not be selected because crew has to wait at least 4 hours. So 10.5 is selected here. 10.5. Now 12 and 24. So 12 is selected. 15.5 and 20.5. So this is 15.5. 21.5 and 14.5. So this is 14.5. 1 and 11. So because 1 is less than 4, we will not select this value. We will select the value 11 here. And 6.5 and 5.5. So we will select the value 5.5 here. 5.5. Now for the fourth row, 4.5 and 7.5. So 4.5 is less. 4.5. 8 and 4. So we will select the value 4. 14 and 22. So 14 is less. 17.5 and 18.5. 17.5 is less. Now 23 and 13. 13 is less. Now 23 and 13. So 13 is less. 2.5 and 9.5. Because 2.5 is less than 4, we are not going to entertain this value. So we will select the value 9.5 here. 9.5. 8.5 and 3.5. Because 3.5 is less than 4, we will not select this value. Instead of that, we will select the value 8.5. Here 12 and 24. So 12 is the minimum value. 17.5, 18.5. So we will select 17.5. So now, as we have made the minimization matrix, now we are going to solve this and make assignments here. So first of all, we are making sure that our matrix is a 5 square matrix, that is 5 cross 5 matrix, and the next step is to reduce the matrix, that is to have 0 in each row and in each column. For that, we are going to do row reduction and column reduction. So let us start first from row reduction. In row reduction, we will select the minimum value in the row. As in row 1, the minimum value is 5.5, and we are going to subtract each element of this row by this minimum value. So 17.5 minus 5.5, so this is 12. 15 minus 5.5 is 9.5. 9 minus 5.5 is 3.5. And 5.5 minus 5.5 is 0. 12 minus 5.5 is 6.5. Similarly, in root B or second row, the minimum value is here 5. So we will subtract 5 from each element here. 16 minus 5 is 11. 16.5 minus 5 is 11.5. 10.5 minus 5 is 5. 5 minus 5 is 0. 10.5 minus 5 is 5.5. 5.5. Okay. 10.5 minus 5 is 5.5. Sorry. This will be 5.5. Now in row 3, the minimum value here is 5.5. So we are going to subtract 12 minus 5.5 is 6.5. 15.5 minus 5.5 is 10. 14.5 minus 5.5 is 9. 11 minus 5.5 is 5.5. 5.5 minus 5.5 is 0. Now for row 3, the minimum value here is 4. So 4.5 minus 4 is 0.5. And 4 minus 4 is 0. 14 minus 4 is 10. 17.5 minus 4 is 13.5. 13 minus 4 is 9. Now in row 5, we can see the minimum value here is 8.5. So 13 minus 8.5 is 4.5. 9.5 minus 8.5 is 1. 8.5 minus 8.5 is 0. 12 minus 8.5 is 3.5. 17.5 minus 8.5 is 9. So now, as we can see that we have zeros in each row, but we do not have 0 in each column because first column does not have a 0. So again we will do the column reduction so that we will have at least 1 0 in each of the column. For that, we will select the minimum value in the column. So for column 1, we can see the minimum value is 0.5. So we will subtract each element of this column by this minimum value. So this is 12 minus 0.5 is 11.5. Then 11 minus 0.5 is 10.5. 6.5 minus 0.5 is 6. 0.5 minus 0.5 is 0. 4.5 minus 0.5 is 4. And as we have 0 in the remaining column, the values here will remain same. So this will be 9.5. This is 11.5. This is 10. This is 0. This is 1. And this is 3.5. this is 5.5, this is 9, this is 10 and 0. Here we have 0, 0, 5.5, 5.5, 13.5 and 3.5, 3.5. Here we have 6.5, 5.5, 0, 9 and 9. So now we have zeros in each row and in each column. Now our next step is to make assignment. Now to make assignment, we will see first we will make assignment row wise, then we will try to make assignment column wise. So first we will see that if there is a single zero in the row, we are going to assign that, and if there are more than one zero, we are going to skip that row and move on to the next row. Same will be applicable for column. So let us see here. For row 1 we have a single zero here, that means we can assign this 0, and once this 0 is assigned, no more assignment can be made in this particular row and this column. So this 0 will be crossed out. Now moving on to row 2, we do not have any assignable 0 present here, so we will move to row 3. In row 3 we are having a single 0, so we are able to assign this 0, and once this has been assigned, no more assignment can be done in this row and in this column. Now moving on to row 4, we can see that we have more than one 0 here, so we will skip this row and we will move on to row 5. In row 5 we have a single 0, so we will assign this 0, and now let us move column wise. For column 1 we have a single 0 here, that means we are going to assign this 0, and once this 0 is assigned, no more assignment can be done in this column or in this row. So this 0 in this row is going to be crossed out. As we can see that all the zeros are either assigned or crossed out, and we can see that we have 4 number of assignments here, and to get an optimal solution or optimal assignment, we need to have 5 assignment here, because it is a 5 cross 5 matrix. So we know that our solution here is not optimal. So what we are going to do is we are going to draw minimum number of lines which will cross all the zeros here, and in order to do so we will follow certain steps. So the first step is take the unassigned row. So we can see that this is the only unassigned row. Take the unassigned row, and if this row has a 0, take the corresponding column. So this is 0, take the corresponding column, and if this column has an assignment, take the corresponding row. So as we can see that here no more 0 is present, that means no more further ticking is possible in this matrix, and now we need to draw lines through unticked rows and ticked column. So we are going to draw lines from unticked rows. So these are 3 unticked rows and ticked column. So as we can see here that we have 4 number of lines that are crossing all the zeros here, because we have 4 assignments. Now in this particular matrix we have 3 types of cells. First is which where no lines are passing, the cell in which no lines are passing. So what we need to do here is we will identify a value theta, which is the minimum value theta, minimum value among the cell which has no lines passing through it. So these are the cells where no lines are passing, and the minimum value among these cell is 3.5. So theta is 3.5. We have taken the value of theta as 3.5 here. Now we need to create a new assignment matrix here. So to create the new assignment matrix, what we need to do here is, for the cell which are having no lines passing through it, so these are the cells which are having no lines passing through it, for this cell the new cost coefficient, that is the new Cij, will be equal to the older Cij minus of value theta. That means for this particular cell, this is 11.5 minus 3.5, so this will be 8. Similarly here 9.5 minus 3.5, this is 6. 3.5 minus 3.5 is 0. This is 6.5 minus 3.5 is 3. Here 10.5 minus 3.5 is 7. 11.5 minus 3.5 is 8. 5.5 minus 3.5 is 2. 5.5 minus 3.5 is 2. So we have written all the values for the cell where no lines are passing. And now for the cells where only single line is passing. So there are cells where only single line is passing. For that particular cell, the value of Cij, that means the cost coefficient for the new matrix, will be same as the cost coefficient of previous matrix. So we are going to write these values as it is. So this is 0, 0. We are going to write these values 6, 10, 9, 6, 10, 9. This is 0. This is 0, 0, 10, 0, 0, 10 and 9. This is 4, 1, 0, 4, 1, 0, 9. And now there are few cells, there are 3 cells here in which 2 lines are passing. Okay, as we can see here, 2 lines are passing. For these cell, the new Cij, that is the new cost coefficient, will be equal to the older cost coefficient plus the value of theta. So as we can see here, this is 5.5, 5.5 plus 3.5. So this is equal to 9. Similarly here 13.5 plus 3.5. So this is 17. Again 3.5 plus 3.5 is 7. So now we have made our new assignment matrix, and we will try to assign in this matrix. So we will follow the same procedure. First we will try to assign row wise, then column wise. If there is a single 0 in the row, we are going to assign that 0, and if there are more than one 0, we are going to skip that row and move on to the next row. And same will be done for column. So let us start assigning here. So we'll start from row 1. In row 1 we have more than one 0, so we will skip this row and move on to row 2. In row 2 we have a single 0 here, so we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. So this 0 is crossed out. Now moving on to row 3, we have a single 0 here, so we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row or in this column. Now moving on to row 4, we have more than one 0 here, so we will skip this row and we will move on to row 5. In row 5 we have a single 0 here, so we will assign this 0, and once this 0 is assigned, no more assignment can be done in this 0, in this row and in this column. So in this column we can see there is another 0, so this 0 will get crossed out. Now we will assign column wise. For column 1 we can see that we have a single 0 here, so we can assign this 0, and once this 0 is assigned, no more assignment can be done in this column and in this row. So here this 0 is also crossed out. Now we can see that we have 4 number of assignments, and we know to have an optimal solution we need to have 5 number of assignment, because this is a 5 cross 5 matrix. So again we need to draw minimum number of lines which will cross out all the zeros here. And so let us start the procedure. So the step 1 is take the unassigned row. So this is the unassigned row. Take the unassigned row. If this row has a 0, take the corresponding column. So this has 2 zeros, so take the corresponding column. And if this column has an assignment, take the corresponding row. So as we can see that this column is having an assignment, so we will take this row. Here also we can see that this has assignment, so we will take this row. Now no more zeros are available here, that means no more further ticking is possible. And now we need to draw lines through unticked rows and ticked column. So we will draw lines through unticked rows and ticked column. So as we can see here that we need to draw 4 lines to cross out all the zeros, because we have 4 assignments here. Now we need to make new matrix here, and for that we will select the minimum value theta from the cells where no lines are passing. So as we can see that these are the cell where no lines are passing, and among them the minimum value here is 1. So the value of theta here is 1. And now in order to make new matrix, we will see that for the cells having 0 lines passing through it, that means no lines are passing through it, for this cell the Cij in the new matrix, that means new cost coefficient, is equal to the older cost coefficient minus the value of theta. So we can see that here it is 8 minus theta, and theta is equal to 1 here. So 8 minus 1 is 7. Similarly 6 minus 1 is 5, and 3 minus 1 is 2. Here 7 minus 1 is 6, 8 minus 1 is 7, and 2 minus 1 is 1. Now 4 minus 1 is 3, 1 minus 1 is 0, and 9 minus 1 is 8. Now we need to see the cell where only single line is passing. So for those cell where single line is passing, we will the new cost coefficient, new Cij, will be equal to the Cij in the previous matrix. So we will write these values as it is in the new matrix. So this will be 0, 0, 2, 0, 6, 10, 9. Sorry, this is having 2 lines. So 6, 10 and 0. Here 0, 0 and 9. 0, 0 and 9. Here we have 0 and 7. So now the next is we have the cell where 2 lines are passing. So for this cell the new Cij or the new cost coefficient is equal to the older Cij plus the value of theta. So this is 9, 9 plus theta, that means 1. 9 plus 1 is 10. So this is 10. Here also it is 10. Here it is 10 plus 1, 11. Here 17 plus 1, 18. So now we have obtained our new matrix, and we will again try to assign in this matrix and see if we get an optimal solution or not. So starting from row 1, we can see that we have more than one assignment. So we will skip this row and move on to row 2. In row 2 we have a single 0 here. So we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. So this 0 gets crossed out. Now moving on to row 3, again we have a single 0 here. So we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. Now moving on to row 4, we have more than one 0, so we will skip this. Now moving on to row 5, again we have more than one 0, so we will skip this, and now we will try to assign column wise. In column 1 we have a single 0 here, so we will assign this 0, and once this 0 is assigned, no more assignment can be done in this column and in this row, so this 0 gets crossed out. Now moving on to column 2, we can see that there is now a single 0 present, so this 0 can be assigned, and once this 0 is assigned, no more assignment can be done in this column and in this row, so this 0 also gets crossed out. Now moving on to column 3, we can see that here one single assignable 0 is present, so we can assign this 0, and once this 0 is assigned, no more assignment can be done in this column and in this row. So as we can see that now we have 5 number of assignment, and this shows that our solution here is optimal. Now let us write the optimal solution for the assignment. So first, A has been assigned to 3, B has been assigned to 4, C has been assigned to 5, D has been assigned to 1, and E has been assigned to 2. And after this we also need to see where the crew is residing. Now to find out that, what we will do is we will see the allocation here. So for allocation 1 3 we will have the value as 9. Okay, so for 9 we can see that 9 is coming from which of the two matrix. So as we can see, A3 has 9 value in this matrix, and this matrix shows that the crew resides in Delhi. So for this particular allocation we know that crew will reside in Delhi. Now moving on to second assignment, 2 B4. So here the value of B4 is 5, and now we need to see among which of the matrix 5 has been come. So 5 has come from this matrix. So this is the matrix for the crew that resides in Chandigarh. So here this crew resides in Chandigarh. Now moving on to the third assignment, let us see the cell C5. So C5 here is 5.5, and 5.5 is coming from this matrix, and this matrix shows that the crew resides in Delhi. So for this the crew resides in Delhi. Now next D1 has the value 4.5, and now this value is coming from this matrix 4.5. So this shows that the crew resides in Chandigarh. And the last assignment E2, that is 9.5, and this 9.5 is coming from this matrix, which shows that the crew resides in Delhi. Okay, so this is the optimal assignment here, and if we need to calculate the value of Z here, or we can see Z minimum. So the Z minimum here is the addition of all the values in the minimum cost matrix. So we can see that here this is 9 plus 5 14, 14 plus 5.5 is 19.5, this is plus 4.5 24, plus 9.5 is 33.5. So this is 33.5 hours. So this shows that for an optimal assignment the crew utilizes 33.5 hours of time in the company's facility. Okay, and this is the optimal assignment, and this shows the residence places of the crew. So hope you understand the lecture. If you like the lecture, please share the lecture. Have a nice day. Thank you.